Hello everyone. In this video, we are going to go over a programming interview question. To supplement the learning of our Golang course, I have decided to start doing solutions for programming problems. This will help us learn syntax of Go and also put concepts into practice before we go on and do bigger projects. So let's get started. I'm going to start with the first LeetCode problem called toSum, which is easy category problem. As we go on solving more and more of these problems, we will start seeing increase in their difficulty. The problem statement for this problem states that we will provide a nums integer array and integer value called target. We need to find two indices of elements in the array or slice that, when added, lead up to the target value or result in the target value. Below here, we are given two constraints. It is very important to understand the constraints of a problem as they will guide us towards our solution. The first constraint states that we can assume that there will be only one solution. This means that we can return right away when we find two elements that add up to the target value. The next constraint here tells us that we cannot use the same element twice. If, for example, our target value was 6 and we have an element 3 at index 2, we cannot return 2 and 2 as the answer. The index value has to be different. In this video, we are going to look at the brute force solution. The brute force solution is the basic solution or the easiest solution that you can come up with. Usually, when solving these problems for learning purposes, we start with the brute force solution and then iteratively enhance it to find a better solution than the one we currently have. Here, I have taken an array or slice, for example, and the elements of array are 1, 2, 3, 4, and 5, stored at index 0, 1, 2, 3, 4. In the brute force solution, we are going to use two flags or pointers. By flags and pointer, I mean two variables to keep track of indices of the elements we are going over. What we will do is we are going to use two for loops. The outer loop is for flag 1 and the inner loop will be for flag 2. In each iteration of outer loop, we are going to have flag 1 at one position while the other flag will iterate through the array or slice. So in each iteration, what we will do is we will check the value stored at flag 1, check it with the value stored at flag 2. 1 plus 2 is equal to 3. Here our target is 7, so this is not our solution. If that happens, what we will do is we will keep flag 1 at position where it has been and then move the flag to next value in the array and then check again for the sum. 1 plus 3 is equal to 4, again not equal to our solution. We move the second flag to the next element, which is 4. 1 plus 4 is equal to 5, again not our solution. Then we move to 5. 1 plus 5 is equal to 6, again not our solution. This is one iteration of the outer for loop for which we iterated over all the elements in the array. Since we didn't find the solution, what we will do next is to move the outer index or the outer flag to the next element and then repeat the process. So in the next iteration, the outer loop will have the variable or index at position 1 or index position 1, and we will start the inner loop or the second flag from index 2, and then we will repeat the process again. 2 plus 3 is equal to 5, again not equal to our solution, so we move the inner flag to the next index where the value stored is 4. 2 plus 4, 6, which is again not equal to our solution. Then we move it to next element, which is 5. 2 plus 5 is equal to 7. This is the solution we want, which is equal to the target value. Since we found the solution, we can see where flag 1 and flag 2 are. As we can see, it's at position or index 1 and 4. So this is our solution and we return the value. Let's now look at our code. Here I have toSums function which takes nums, which is an integer slice, and a target value, which is again an integer, and it returns the solution or the index value which add up to the target value. Inside the function, I first create a result slice to store the values which have the result. Inside it, as you can see, I have the outer loop for our first flag. For I is equal to 0, I less than nums I plus plus. Inside the outer loop, I have another for loop which starts at next position or I plus 1. And then a correction here, it should be j here So it goes to the end of array and j++. Inside it, we check if element at index I plus element at index j is equal to the target, which means we have found our two indices that result in the target value. So we can append the result or index I and j to our result slice, and right away we return the result. If we never find such solution, we will get to the end of the for loop and return result, which is an empty slice. Now let's try to call our function toSums and see what we get. Here I'm just going to create a num slice which has values 1, 2, 3, 4, 5, and then I'm going to store the result of toSums in result variable, pass nums and a target of 7, and then we print result. So if everything works out, we should see index 1 and 4 return, which is the solution of our problem. As you can see, 1 and 4 were returned. This is the brute force solution for our problem, or the easiest solution that we can find. Now let us go back to our board and discuss the time and space complexity of this function. So in this solution, to iterate over the elements of the array, we use two for loops. Each iteration of the outer for loop, we scan the whole array. That is, for one iteration of the outer for loop, we go over the whole slice or array. And if we find our result in one of those iterations, we return it right away or continue on to the next iteration. Whenever we use a for loop inside another for loop, the time complexity is usually equal to n square, where n is equal to the length of slice or array. That is because in the worst case, the two elements are the last two elements that add up to the target value. So to find them, we would have to go through the complete array or slice. We talk about the worst case here because when we measure the time complexity of a solution or an algorithm, we always look at the bottleneck. Practically, it may be okay to use a solution that performs well in average case if the worst case is rarely encountered. But in programming questions or programming interviews, you always consider the worst case, which in our case is when the elements that we are looking for are at the last two indices or are not in this slice. Anyhow, let's get back to our discussion. So the time complexity, as we saw, is n square because for each element or for each outer loop, we go through the whole slice. So if there are n values in the slice, we have to iterate over n times. So n into n, n square. For the space complexity, since we are not using any external data structure to solve our problem, or we are actually solving our problem in place, the space complexity is equal to O1, which is constant space. The only external data structure we used was the result slice, which in any case at maximum will only store two values. So the space complexity is O of 1 or constant time, and the time complexity is O of n square. In the next video, we will look at another approach of solving this problem which has a better time complexity. That's it for this video. I hope you enjoyed the lesson. Please feel free to ask any questions you may have in the comments under the video or reach out to our Discord server. Thanks again. See you in the next video.